Alright, so I think I'm recording. Let's take a look at our inverse functions, some problems. Alright. I get all tangled up in these wires. Alright. Well, there it is. So in the first problem, we're given a set of ordered pairs. So we know that any set of ordered pairs is a relation, and if every element in the domain corresponds to exactly one element in the range, then the relation is a function. So they tell us it's a function, but let's just confirm that. I see 9 here, and I don't have a 9 that's repeated in the domain, any of the x-coordinates. I have a 3. I don't see any repeats of a 3 in the x-coordinate. The same for 0, same for negative 3, and the same for negative 6. Now, the inverse of a function switches the domain and range. So when you have a list like this, it's just as simple as switching the x and y coordinate. So we have a new relation that negative 3 is related to 9, that negative 6 is related to 3, that negative 3 is related to 0, that 6 is related to negative 3, and that 9 is related to negative 6. So did I switch? Make sure, yeah. Now, so here is the inverse. Is this inverse a function? Well, no, because I can see that if I asked you what is negative 3 related to, you could say 9, or negative 3 is related to 0. If it were a function, negative 3 would be related to exactly one value, not two values. So the inverse is not a function. Alright, so that one was pretty easy. The second one looks to be a similar problem. So if we just confirm that this is a function, here's 0. I don't see any other zeros in my list. There can't be a member in the domain that is related to more than one member in the range. So I can't see any repeats for the x-coordinates. 2, it's the only 2 that appears. Negative 1, among all these x's, it's the only negative 1, the only negative 4, the only positive 1. So this is definitely a function. The inverse of this function is just simply switching the domain and range, which means switching the x and y coordinates for every point. Alright, so this time we see the negative 4, I don't see another negative 4, positive 22, I don't see another positive 22. With a short list like this, you can just check it by inspection. Remember that we did suggest that you can make a mapping where you list the numbers in the domain. That's my domain set. And then if I list the members in the range, and if I just draw arrows for the members in the domain and what they're related to in the range. We see a couple of things. One, it's easy to inspect and to see that it is a function, and furthermore, this function is also referred to as a one-to-one function. Because for a one-to-one function, every element in the domain, every element in the range, was related to exactly one element in the domain. So not only this relation achieved the title of function, and then this function achieved the title of a one-to-one function. And it's only one-to-one functions that have inverse relations that are also functions. So we know that because this original function can be thought of as one-to-one, that the inverse is also a function, and it's a one-to-one function as well. So this inverse relation is a function, and they are both one-to-one functions. Alright, so I'm going to stop the video and then do the other ones on individual videos. So I hope this helps.